Okay, let's say you were given a list of numbers in random order and you had to rearrange them so that they are sorted from smallest to largest. Which approach would you take? One of the simplest sort algorithms is called bubble sort, although it's certainly not the most efficient. We start by looking at the first two numbers and we can see that they are not in the right order. 2 should come before 6, so we need to swap them. We then move along and look at the next pair of numbers. This time they're in the correct order, so we don't swap, we just move along again. Now 5 should come before 9, so we swap. And we just continue in that fashion. For each pair we swap if necessary, until we reach the end of the list. At this point you can see the list is still not sorted correctly, so what was the benefit of doing all this swapping? Well, you might notice that we've moved the 9 to the end of the list, which means it's now correctly placed in the sort order. And more generally, for any input, we'll always end up with the largest number at the end of the list. This means that the section of our list that is still random has been reduced by one number. So now we just start again from the beginning. We compare 2 and 6 and leave them in place. We compare 6 and 5 and swap them. And we repeat these steps until we reach the end of the random section. Notice that we do not compare the 6 with the 9 because we already know that the 9 is in the correct place. So at this point, as before, we know that the largest number in the random section is now at the end. So effectively, our random section has been reduced. You're probably seeing the pattern now. For each iteration, we start with the first two numbers and work our way to the end of the random section, and then we reduce the random section by 1. Of course, we are finished when we complete an iteration that has only two numbers. In this case, there's no need to swap the 1 and the 2. And so we're done. We have correctly sorted the list. But in some cases, we don't need to continue until we get down to just 2 random numbers. Let's look at an example where we can short circuit and finish the process early. As before, we assume the list is random and begin our first iteration of comparing numbers. This time the number 8 is the largest, so it will be moved to the end of the list. Then, once again, we reduce the length of the random section and start again. But this time there's something different about the random section. All the numbers happen to be in the correct order, so we don't perform any swaps. That means it's not just the last number which is in the correct place. All the numbers are in the correct place. So the rule is this: if we get to the end of our random section without performing any swaps, we don't need to perform another iteration. We have sorted the entire list and are finished. So there we are. That's the bubble sort algorithm.